Welcome to In the Open with Luke and Joe. I'm your host, Luke Schantz, and here's my co-host, Joe Sepi, and a big welcome to our special guest, Rama Akkiraju. Before we get to our show, don't forget to like and subscribe. In this episode of In the Open, we bring you a conversation with Rama Akkiraju. Rama is an IBM fellow and CTO for AIOps. We will be discussing the emerging AIOps landscape. Before we welcome Rama to the show, let's say hello to our co-host, Joe Sepi.
Hey, Luke. How are you, my friend?
I'm doing well. How are you, Joe?
I'm all right. You know, it's funny. Last week, I really felt like we had hit spring, right? The frogs were out, the buds on the trees. I was super excited. And then it's super cold now. But I'm trying to sell my house, so the realtor recommended that I open the pool. So even though it's like getting below freezing, I've got the pool open and ready to start summer. So it's kind of weird weather.
Turn the heat up. I'm coming over. We just have to keep the frogs out.
Yep. We got a plan. Let's do it.
And Connecticut, it really is. I mean, there's a lot of frogs in Connecticut. Who knew? I mean, they're chirping everywhere. And I cleared an acre of my land with a big brush hog this past week, and I was using my pickup truck to pull tree stumps. And to me, spring has sprung. I don't feel the cold. Maybe it's because you're a little farther north. I don't know.
Yeah, and I mean, today I was out in just a sweatshirt. So I'm with you. Spring is here. Let's just roll with that.
Without further ado, let's welcome Rama. Let's see what the weather's like where she is.
Hi, Rama.
Hi, Joe. Hi, Luke. You know what? You both should move to Bay Area. It's 61 outside, and the high is 71 today. And we've been having this great weather since February, maybe. You know, our spring came back in the first week of February. All the flowers started blooming then. So
wow.
Move to the balmy California and pay the taxes, sunshine taxes.
That sounds great. I would love that.
Pre-pandemic, I spent so much time in California at the conferences that they did tax me a little bit.
Yeah, there is, good weather doesn't come for free.
Yeah, that's right. Well, welcome, Rama. Thank you for being with us. I'm really excited to talk to you about, all the stuff we have to talk about today. But maybe it'd be great if we started with you, telling us a little bit about yourself, your background, and let's start there.
Sure, it's a pleasure to be on your show, Joe and Luke. As you've introduced, I'm Rama Akkiraju. I'm an IBM fellow and CTO for AIOps. We're going to talk a lot about it, so I won't get too much into it. But just a little bit about myself. I've been a lifelong IBMer, and I've started my career at IBM Research back in the TJ Watson Research Center in New York, and worked over there for a number of years before moving to California to join the Almaden Research Center. So been in research for quite some time, and then I did a bunch of work when the IBM Watson division was formed, developing a set of foundational AI services around understanding people better, their personality traits, emotions, sentiments, communication tones, those sort of things. And after that, done a bunch of work around foundational AI services in Watson, expanding to many languages, which then brought me to my current role as the CTO for AIOps. So excited to tell you all about AIOps and what we are doing, where we are.
That's great. I'm excited to talk about it too. And I also just love, I've been at IBM for almost 6 years now, and I love the whole research aspect of IBM. I used to live pretty close to the Yorktown facility, and Luke and I have been over there a few times, and a number of the research facilities. And I find it fascinating too when when you see research turn into, for lack of a better term, a product, something coming to market. And I think what we're going to talk about today is really, great example of that. Maybe you could start off by just telling us what is AIOps? What are we going to talk about today?
Yeah, AIOps is really all about applying AI for optimizing IT operations management. It's a term that's coined by Gartner, which is often actually confused with ML ops. And it's poorly coined, I would say, but if you have heard MLOps in the community of machine learning, it's more about managing the machine learning models and the CI/CD aspects of machine learning models. Whereas AIOps, on the other hand, is really all about the overall IT operations management and how can you optimize that by bringing AI. So what does that mean? So it's about IT systems that you're running in production. Any major IT system, think of it, that we are interacting with, airline reservation system, think of retail shopping systems that we are interacting with, or banking, payroll, everything that we interact with, they're all running in production, and they have to be up and running 24/7 because customers depend on those systems. But as we know, IT systems, both software and hardware, can have problems, and when they do happen, there will be outages, and those outages can sometimes be disastrous, life-threatening, sometimes could be significantly impacting the revenue of companies. So how can IT operations management is all about staying ahead of that game, ensuring that these applications are up and running all the time or as per the service level objectives that you set for those applications. And in the process, having the right kind of monitoring, the mechanisms for detecting, diagnosing, and resolving problems as they happen quickly, and ideally even catching problems early in the pipeline that they don't even happen, that your systems are up and running and there is no outage at all. So that's what is the IT operations management. AIOps is all about how do you bring AI to make it happen, to automate several of the things that might be automated. Basically, if you think of the grand vision of AIOps, I would say it is about getting to a point of self-healing, self-managing, self-monitoring, and self-optimizing IT systems.
There's so much hype around the term AI, and I feel like it's so interesting to kind of hear that we're getting to a point where this is becoming a reality, right? There's the sort of science fiction AI, and then there's the real deal. So my question here would be sort of, what are the factors that led this to become the reality now, or how did these pieces come together?
Yeah, that's a great question. So if you look at the trends and the trajectory in the industry of IT systems, from development to deployment to operations, there have been tools and products out there in the market for the past 2+ decades, if not more, to help manage IT systems. And yes, of course, they have been there. So yes, it does beg a question of what's new now. Why is it becoming a big catchword, and what are we and others are doing in this space? So what was being done in the past is, as the systems are running in production, you can monitor different kinds of metrics associated with those applications. Right? These are metrics related to their availability, the latency of the applications, any kind of error rates or HTTP error codes that the systems may be writing, or even database, memory, CPU consumption. These are the kinds of metrics that traditionally applications and IT operations administrators have had tools to measure, and they would look at those, and whenever there is some kind of a deviation from what is expected of the normal, anomalies or issues are raised, and they would deal with them, and that's how IT systems have been managed. Of course, that's required, that's important. And then the whole field of application performance monitoring came about in the industry, which is to go in and implement some observers that will send all of this important data, and then you can also capture the traces of the applications and create a dynamic topology or a graph, if you will, that shows what is calling what at both application level and what's running where at the infrastructure level, and so on. And so all of this data has been used, and tools were developed, and IBM itself had a suite of tools with the acquisition of Tivoli back in a couple of decades ago. All of these were being used. The problem has been that Yes, they will help you manage and detect and diagnose to some extent, but they are missing out on actually monitoring some other important kinds of data that existed but was never really tapped into. And those were application logs or system logs or IT incident management tickets. Um, even during the software development process itself, the various kinds of software development, um, uh, Git issue comments and the descriptions of deployments and changes that are happening and all that. All of this is very valuable data that's very useful in detecting, diagnosing, resolving, and even preventing problems from happening. But this type of data is unstructured or at best semi-structured, and it has a lot of natural language in them, and this was very hard to process. If it were metrics and traces, they're structured data, right? They come in bits and bytes, they come in numbers, and there are specific measurement metrics for those. you know Error rate per second, it is 20% in 15 minutes. Memory this much, and you can set a threshold, and if it exceeds that, let me know that, notify me with some kind of a pager duty type of a notification. Those are numbers, and when you have numbers, they're much easier to process and mathematically. And traditionally, we've had a lot of time series algorithms and others, and that we were able to use to process, and therefore that's where the industry was at. So why now? What's the opportunity coming to that point? With the advancements in AI, wherein we can now process natural language and actually understand the natural language, understand to the extent that convert those natural language words and tokens into bits and bytes and vector representations in a way that we can mathematically process them, at least at a first level, and at a deeper levels, get into the semantic meaning of those natural language terms and natural language documents and such. There has been tremendous advancement, especially with um, in the area of natural language processing with transformer models that have come about, which are called as BERT or GPT-3. So the bottom line is that we now can, and with more deep learning models, that then you make use of those vector representations of text words, we can now process these unstructured and natural language data, also convert that into bits and bytes, and use deep learning algorithms or other kinds of statistical algorithms to derive insights from it. That is the new opportunity. That wasn't there before 2 decades ago. That's because the advancements in the natural language understanding, the types of models that we can use to convert these bits and bytes, these words into bits and bytes, and the deep learning models, algorithms that can process those large scale natural language data, which got converted into vector forms. All of that happened in the past decade. And with all of those advancements, we can now start to tap into the potential of these unstructured data. So that's how we got started and said, okay, now let's bring in logs that applications and systems are writing, so that we can detect problems early and we can explain the problems better, because logs have so much explanatory power. They're written by developers. When the applications are written, they have information. Yes, they have some structured codes, in message formats, informational message codes, error codes, and all that. But apart from that, they also have very useful information message, and also sometimes they embed the whole, what is the SQL statement that was run, right? That itself will give you a lot of explanation about what SQL statement run, where it got stuck, and so on. So logs have a lot of that explanatory power, and also have that ability to help you detect problems much early. Like, for example, even if a certificate were to expire 24 hours from now, those warnings start showing up in logs. If you just look at metrics, everything looks just fine. But from logs, we can detect that, hey, it's going to expire. Let's take a proactive action, right? So that is the advantage, and that's the processing. Similarly, take incident tickets, where when a problem occurs, people actually go in and take a lot of notes to say, hey, such and such occurred, we tried this, didn't work, this tried this work, and this set of 5 steps eventually worked, and now we closed the ticket. that information of what were the symptoms, what was the problem, what was the diagnosis, what was the root cause, and what action was taken to perform to resolve it, is a gold mine of information that can be used to match the current problem with the prior ones and suggest recommendations from mining that, and also use all of this information to even predict what kind of problems will occur if you're deploying a change and prevent those from happening. So that is the power of this unstructured data that was untapped before, and now we can get into all of that and tap into it. So with AI, we can now get into logs and incident tickets, and now add to that the previous structured data like metrics and traces that we were already able to process. We can now construct a full diagnosis. It's almost like FBI now has access to so many more puzzle pieces that they can now put together to solve their puzzle, to really understand whether this is something that they need to go after, or this is something that they'll continue to monitor, and the low key, for a little while longer, to see if it's something that's really something that's going to cause a problem or not. So it's that, I mean, we have more clues, more, and because we're able to put more clues together, the puzzle pieces are coming together. You can now derive better insights, take more proactive actions, and in the process, this allows us to become more self-managing, self-optimizing, and self-healing in the process, and leads to more automation. So that's a long-winded story, but the gist of it is that, yeah, AI, why now? It's because we can now process semi and unstructured data in addition to structured data, which allows us to tap into better insights and take better actions.
Yeah, it's fascinating to me because I've seen over my years as an engineer, like the explosion of DevOps, and early days we had PagerDuty, and something would happen and you got to log into the server and figure it out yourself and make changes. And over time that's gotten better, and we've gotten all sorts of better tools and more logs and information. But it seems like adding AI is like a whole nother level. It's like exponentially more powerful. And but it also sounds like it's a lot of data. Like how do you what maybe you can tell me a little bit about how you manage that much data and unstructured data, and how you kind of process that.
Yeah, that is an interesting one. Yes, logs come in large volumes, depending on how verbose the applications are, and depending on what verbosity you have turned it on in the time of production, and depending on the scope of the monitoring that you're doing. Right? If you're monitoring mission critical applications versus monitoring everything that's going on, log data in itself can run into terabytes per day. So in order to process all of it, yes, you're going to need a lot of compute, a lot of resources, and all of that. So what we have learned from our working with our customers is the following, and that's logs. Same thing goes for tickets, depending on how good your documentation processes are around managing your incidents. For every incident, there could be a good amount of documentation, and if you have many applications, there could be many tickets over a period of time, and it's a lot of data. So some best practices we've been able to derive from working with clients. So with metrics, because they tend to be structured, even if you monitor hundreds and thousands of those metrics, the amount of data that you're processing is still in bits and bytes and is small. With logs, it can add up. But most enterprise clients have, or anybody who's running IT systems, have some kind of tiering. There are some crown jewel applications that are really customer facing, and the availability requirements for those applications would be at 99.99999. Because they are mission critical, crown jewel. That's why. Then there are tier 2, which are being called by those applications. For those ones, if there are problems, It doesn't have to be absolutely real time, near real time to within a day might be okay. And then there will be some applications that are internal where, if there are some issues and such, there is enough redundancy set up, or that it's not so mission critical that you can deal with them in a non-urgent fashion. So typically we see this kind of tiering. So because the volumes can be huge, you can be judicious about where and what all applications you want to monitor for logs in production in near real time, right? You probably want to do that for applications that have 99.999 or 99.95 kind of availability requirements, because there the amount of leverage you have, or the amount of time that you have to react, and the remaining error budget, if you call that, at any given point in time, maybe of the order of a few minutes per month. So you can't afford to waste time or lose time. So you've got to be proactive in those situations and monitor logs and everything and be on top of things. For other things, maybe you don't have to. And so that's kind of how we guide our customers to that. You set up real-time, near real-time monitoring for those mission critical applications. And for the other ones, the second tier, maybe, even if you don't give the most high-end compute or enough resources, they can process them slowly at their own time, within a day, within half a day, let them know that there are problems. For the third kind, maybe you would use high volume log type of data for primarily explanation purposes, where you let metrics tell you that there is a problem, and then logs will help you diagnose the specific place or the root cause for the problem better. So it really boils down to that. It's about being judicious about which applications have what kind of service level objectives, and based on that you set up your monitoring and the further processing and insights management and resolution management accordingly. Otherwise, it becomes the total cost of ownership of applications and the costs of monitoring and getting insights from that might outweigh the benefits or revenues that you may get from applications. Sometimes depends on volumes, depends on such, but yeah, that kind of tiering and judicious planning and designing based on that, going for the specific use case, will be very helpful.
I have a question, Rama, but first I just want to mention if anybody's listening live, if you have questions, please feel free to throw them in the chat. We're monitoring. There's actually a lot of chatter and activity going on. I just wanted to say, like, Marco says, thanks for sharing. And Tony, who is our Tony TV, who tunes in every week. Thank you, Tony. He says, great to know these things, Rama. Love the sharing done by IBM on this. So thanks for tuning in, Tony. And I agree. Thank you for sharing, Rama. The question I had is, well, first, I have a comment first, is what this reminds me of, the way that you illustrated how these tools compounded over time, and we got to a place where we're able to process this unstructured data and get, useful, actionable bits and bytes that can be combined with the metrics. It reminds me, there was this show from the 1970s on BBC called Connections by this guy, James Burke. And he was like kind of like a British Carl Sagan or Neil deGrasse Tyson, how he can take, the very complex thing and sort of present it to the everyman. But what they did on that show, and it reminds me of how you illustrated this, was, we love to watch a documentary that's like the history of the combustion engine, or like, this is how, something was done. But in reality is much more complex and messy. And you have these sort of, building of tool sets over time that then all of a sudden make something become possible. And the one that he illustrated that I love the best was like the limelight, the first like incandescent lighting. You can actually trace it back through this crazy connection of like the invention of the sextant and the, surveying and building medieval castles and the, measuring of gunpowder for cannons. And it was like this really crazy connection of all of these inventions that then made this thing later possible. And it wasn't just like out of nowhere. It was like it really built over time. So that was just my comment. It also, one other comment, it also reminds me of how, Kurzweil talks about how, mapping the genome. It was like for so long, not much of the work was actually done. It took years and years and years, but then you had this compounding tool set. And then in a very short period of time, they actually finished most of the work of mapping the genome within like the last few years of a 15-year project. So I think it's interesting. That's like, we've been talking about AI for a while, and it, not just us, the world, right? We've been in our minds, but now we've reached a point where these things are coming together. It's very exciting. But my question was about, you mentioned the tiers of applications. My question is about the enterprise and, how vast a hybrid cloud digital estate is, right? From on-prem to the cloud to, all applications running everywhere. So I guess, how is that handled, right? Because I imagine that presents some challenges as well, like legacy heritage systems written in COBOL and modern apps in React. And it's all of that needs to come together to have a system like this work.
Yeah, absolutely. So just a comment on the comment that you made before I get into it. So absolutely, the history of invention is hardly linear in any field, right? And it's very interesting how we build on, inventions over time that look seemingly unrelated, but over time you pull from each one of those, and you're now able to suddenly make happen something that wouldn't have been possible. And in the case of the broader AI and the application of AI to different fields, that same thing is happening, right? I mean, if you look at computer vision back 3 decades ago, at some point it was the in thing, and then it became, so it required so much compute that it was not realistic, and there were no meaningful applications that you can build from it. And then that continued, we went into this revolution of deep learning, and that kind of opened up things for so many different domains, those set of algorithms. Right now we are talking about IT application management, operations management, and there's so many different domains to which these technologies apply. So absolutely, and I think together as a community, we benefit from all those and build on it. So nice observation there. So coming to your question about the complexity of enterprise real estate, and the width and the depth and the breadth of enterprise applications, and what does it mean to manage them all and manage the operations, and how can AI ops help there? You're absolutely right. I mean, if you take any large company, say a bank or an IT company or a retail company, insurance company, take in any particular domain, there are always applications that are born on the cloud, Kubernetes, cloud native, the new ones, but then there are 80% of likely the rest of the applications are built in the previous decade, still doing mission critical things, running. Some are more on the written in latest, if not the absolute latest technologies, maybe in programming languages like Java and C. Other ones still, 3 decades earlier developed in COBOL, Fortran, and believe it or not, those things still exist and they still run, and they are running on transaction systems and mainframes and so on. So there is, at any given point in time, there is a full real estate that spans across all of these. Some that are running in traditional environments, some in virtualized environments, some on more cloud native Kubernetes types of environments, hybrid clouds, multiple cloud vendors, some on-prem, some on running on SaaS, internal clouds versus public clouds. All kinds of things exist. So when we talk about IT applications running in these types of heterogeneous environments, the question comes about, okay, what does it mean how do you monitor all these applications in real time and still be able to provide the right kind of insights at the right time? What it means is that it requires these observers to be deployable in all those environments, so that we can actually listen and observe and gather the metrics associated with what's happening, how these applications are running. If you take the more cloud native latest versions in Kubernetes and such, they come with more of the the layers for monitoring and all of these things already packaged into the containerized environments. Whereas in the more traditional ones and the previous decade types of application environments, you don't have that. So you still have to go in and build those observers and then have the right kind of connectors that can pull the topology and the information and pass that over to AIOps for insights and such. So that's what makes it very this process complex. But what can we do to cut short that process of going to a client and doing that every single time, right? So as a product, what you want to be able to do is to really have at least have coverage for 80% of the most frequently used types of applications and environments, have pre-built connectors, pre-built observers, pre-built hoses that you can simply go connect to. And then for the rest of the 20%, you may still have to do some custom work within a client environment. So as you increase the scope and breadth of these connectors that in the product, then hopefully the amount of custom work that you have to do in any given client environment will be small enough. So that's what we do in AIOps as well, because in order for you to collect metrics, traces, logs, tickets, and even Git comments and change deployment change comments and such, you have to be able to connect to all of the different tools, a plethora of tools that customers use in their environments, right? There could be using application performance monitoring tools from different vendors. They could be using log aggregation tools from different vendors. They could be using ticket management tools from different vendors, or maybe homegrown ones for all of these things. Same thing for code and the overall software development processes. They may be using different tools, platforms. So if we have pre-built connectors to the most frequently used and popular ones, then we can simply connect using those hoses and get all the data that we need to do the analysis and provide the kind of insights. So that's a typical approach that we use, and that's how it makes it more affordable for clients also, rather than having to do custom work every single time. But you're absolutely right in pointing out that when you talk about IT operations management, you're really talking about IT systems that are running across the entire enterprise real estate in different heterogeneous environments and all over in on-prem and public and private and hybrid environments. So it's a complex environment to bring all of complex environment and the process to collect all the things that you need to derive the insights and to provide insights at right time is tedious. Nevertheless, you something that must be done, and the way to do it is to build this as much as possible, the pre-built connectors and even pre-built models. I'll stop there, but you can ask me the question about pre-built models, because I'm super excited about that and I'm happy to tell you. But let me pause there.
I mean, I'm happy to let you go right into it. I think it's really fascinating how complex these situations can be, and but I imagine just like the way the landscape has been developing over time, like you're saying, these connectors are emerging, and you're able to start and plugging things together and bringing it all into one space to really analyze. But yeah, tell me more about the pre-built models.
Yeah, so if you take any kind of an enterprise real estate, especially here we are talking about machine data, right? So machine data being, logs, tickets, that logs and metrics. More so, tickets are human authored. Sometimes they can be auto generated by systems also. But this machine data is specific to the machines or the systems that are writing it. So you don't have ahead of time, before you deploy your product, you don't know what applications the client has and how they are built and what environments they run in, what kind of logs they write. So you cannot build models ahead of time. So you go in there, you with your algorithms and the code and the pipeline and everything, and you say, give me some of your data, and so that the system can learn what is a normal behavior or what kinds of things anomalies occurred in the past, so that you can detect those kinds of issues and problems and start to deploy these models that can really work in the client's environment, right? So what that basically translates to is you cannot really pre-build anything. You have to go into a client environment and do everything. Because it's so machine dependent. It depends on the applications and the data that they write. However, if you look at the more traditional natural language processing domain, say a speech to text recognition system, or some kind of an document understanding, or intent recognition in chatbots, because they've operated on natural language, and natural language in any given language, like say if you take English for example, is well known, understood, the grammar of it is well understood. So you can actually collect more Wikipedia data and general purpose data from public domain sources and build those models and pre-build models. So if you can use a speech to text recognition in English, it may work just fine for many use cases, even though there are some accents that it may not detect very well that are specific, or some specific domain language it may not detect. But you can build a pretty good base English speech to text recognition model today. Can we say the same for any kind of a log anomaly detection or metric based anomaly detection for some airline reservation system that uses proprietary services and components and code within a particular airline company? No, you can't pre-build things for that, because you don't know what kind of logs it writes ahead of time, right? So that's been a challenge for the AIOps domain, and we've been thinking about, okay, how can we short circuit the amount of time and data that's required to learn within the client's environments? Can we do anything ahead of time? And it so turns out actually we could. There are two ways to think about it. One is, you can still, with a lot of taking the IT domain data, pre-train what are called these foundational models, which is basically language of the logs and language of the IT domain, the logs, tickets, what kind of words occur more frequently. Train these foundational embedding models and create vector representations of those ahead of time, which will work well for IT domain. That much pre-building that you can do at one layer. Another layer that we thought about is that, well, in enterprise applications, if you look at databases, web servers, and web application servers, there are some standard products out there, say DB2 database, Oracle database, or a WebSphere application server, or BEA application server, whatever, right? These are pretty standard middleware software whose versions and whose logs and whose error codes and issues, what actions to take to resolve, they're all published already because these are pretty standard products. That documentation exists. So we can even pre-build whenever there is a problem in WebSphere or DB2 or Oracle database, or whenever with this kind of a code, we kind of know to process it ahead of time, and we know what actions might help resolve it, because there are some well-defined knowledge center articles in the public domain that tell you that you need to run this kind of a script, or you may want to run this kind of a data collection gathering script in order to diagnose the problem, and those sort of things, right? So that is the level. So if you look at standard infrastructure syslogs, for example, system logs, you can Linux of a particular version, or a particular Z operating system particular version, they are published, that information. So at that level, at application or software middleware level, and even the base foundational level of the domain, the vocabulary of the IT domain, you can, it so turns out, pre-build models so that you are more well ready. When you go to the client environment, you still have to learn based on the client data, but you have a good chunk of the foundational pieces ready. So that will short circuit the amount of data and the amount of time it takes for the AI models to learn about the client's own specific domain and log or ticket data to make predictions about anomalies or risks or whatnot. So that is an interesting breakthrough as well, where we can do a good chunk of work ahead of time before we take this product or the system to clients' environments. That's another interesting new, I would say, dimension and a new frontier that we're exploring in AIOps.
Yeah, that makes sense. If you can do some of that stuff beforehand and then build upon it, yeah, there's that makes a lot of sense. And it reminds me too of like sort of, I'm an open source engineer and work a lot in open source and think about open source platforms and stuff as sort of like a foundational thing that you would build your application specific stuff on top of. I know we talked about this a little bit in the prep call, but I think it's worth asking here, like what sort of, if any, open source tooling is involved in the AIOps space. I know we talked a little bit about, cloud platforms, but like you said, that may be a small percentage of the overall applications that you're going to be working with are actually cloud native. But are there any open source tools that are involved in the AIOps space?
So if you look at, I would break it down into two categories. One set of category of tools is specifically for building the product itself. There, of course, there's quite a bit of open source tools, GitOps types of things that you can leverage to, increase the velocity, the continuous integration, continuous delivery, the CI/CD aspects of building the product and such. That is applicable across the board. So there is a lot of open source tooling out there that we build on and use. Then there is, if you talk about specifically the algorithms themselves for detection, like the anomaly detection algorithms or the diagnosis types of algorithms that we use, or the algorithms for correlating different disparate pieces of information to create a holistic problem context or to predict risks and so on. If the general purpose AI or ML algorithms are, of course, out there in various toolkits, like in LTK, if you're doing Python programming and such, where you can, or TensorFlow, depending on which framework you're using, or PyTorch, you can call, whatever algorithm you want to use. If you want to use the principal component analysis algorithm, if you want to use SVM algorithm, if you want to use a particular kind of a deep learning algorithm, you can use those. And so that became like, that's pretty much table stakes for everybody. So I'm not particularly calling those out yet. Yes, there are algorithms. Let's say if you look in the public domain for log-based anomaly detection, or time series algorithms for metric-based anomaly detection, and so on. But this is where I would say, our secret sauce comes into picture, where we're not necessarily using the ones that are in the public domain there, because we work with our IBM research colleagues and partners where, there's a lot of excellent mind power, where we have the next generation advanced algorithms in several of these cases that we've built in-house, and those are the ones that we are using to power the detection, diagnosis, risk prediction types of algorithms. And there are different aspects to this whole thing, which include, how well do you select data, how when a bunch of data is given, you want to be selecting the right and good quality data and discard the ones that don't have enough information in them. But in doing so, you want to make sure that you're not introducing biases for the data. So there are different criteria and considerations, and not just in the algorithms, but also in the way you manage your data and the pipeline associated with data and such. So there we use mostly our own algorithms. So I would say, the foundational components, yes, there are lots of open source ones that pretty much are table stakes now. Everybody uses out there. The more hardcore algorithms, when it comes to actual detection, diagnosis, and resolution, incident management, incident avoidance, and those sort of things, we have our own set.
That's so interesting. And I wanted to mention here, so we had I think you addressed some of this question, but we had a question from Stefan, who is working mainly, he had been working in Austria. He actually had worked with IBM a little bit at one point, but he's in the healthcare industry. And he was asking about, he had a multi-part question. It's too big to fit on the screen, but he was asking about, issues of like internationalization, especially language-wise. So developers, there might be a resource out there, and then they don't necessarily can't read the documentation because it's not in that language. And then I guess also specific things about, like say the healthcare, right? He's interested in healthcare, but I imagine we could apply this to fintech, into, other verticals as well, where, and I think you've kind of already answered this, but I'm just wanted to mention it. And then the third is, and Joe, you may have an answer to this, if there are folks who are interested in topics like that, how can they give back, right? So maybe you're bilingual and you're in France and you speak, German and French, and there's some and English, and there's some, open source algorithm out there, or there's some work that's being done, but it's only in English. So I think the answer there is, people have to get involved, especially in the open source space. But, I'll pause there. It's not exactly a question, but I just wanted to acknowledge that, we've got a lot of engagement in the chat right now. People are really interested in what you're saying.
So on the language side of things, actually, it's more than internationalization. When you think about logs and incident tickets, logs, we have seen, with the Japanese customers and German customers, Spanish customers, when engineers write the code and they're writing their logs, they may have the error codes and some part of the description in English, the rest of it is in their local language. So the same thing with incident tickets, depending on which language and where the engineer who is closing out the ticket is, they write it in their language. So what this translates to for AI and machine learning models and natural language processing is that the way we are able to process and parse this data, we have to be able to deal with languages. And it's not just internationalization of, making documentation available. Yeah, this resolution, this ticket data will translate it or, make it available in different language. It needs to be in real time, be able to process the data in that language and understand the tokens and whether there is enough, sometimes there is some languages are token delimited, space delimited. Some languages are, they're symbolic, they don't have any space as a delimitation at all. So the tokenizers that you use based on language is important. And for that, you also need to be able to detect the language that the particular artifact is written in. Is it in Korean or Japanese or Chinese? If there is no space delimitation, you still need to be able to detect the language and apply the right kind. And that's where, again, these foundational models and the transformer models like BERT and GPT-3 that I mentioned become very important, because they over the years they have become very multilingual, and they can actually process all of the natural language written in any kind of language and still be able to translate them into the corresponding vector representation, so you don't have to worry so much about it. So internationalization question, although seems like a very at one level, at surface level, if you peel the onion at one level, it goes it stays at one level, but it's actually much deeper, because in the case of these IT systems, especially natural language types of data like logs and tickets, they could come in any form or shape, and we need to be able to process them. And so this is an interesting, problem and challenge that need to be tackled. Then there was this other question of, for specifically for healthcare versus other domains. AIOps is actually a cross-domain application or a solution, right? It doesn't matter whether you are monitoring healthcare-related IT systems or fintech-related IT systems or retail-related IT systems. They are all systems that, basically software running on hardware that could run into problems, and we need to be able to stay ahead of the game, basically. So in that sense, it's not very domain specific. So if you're talking about specific healthcare applications in a more broad general purpose AI, if you're talking about specific use cases where you're developing a radiology assistant or a mammography radiology reading types of software, then it starts to get very specific to healthcare domain. Here, AIOps is, we're really talking about, independent of what domain these software systems are serving, they have reliability, availability, latency requirements, and we need to make sure that we're monitoring the right kind of metrics to keep these systems up and running. So it's very cross-domain in that sense. So we don't concern ourselves so much with the specific industry domain.
Stefan replied, he said, "Thank you. That was very helpful."
I'm glad that answered your question.
That's great. I'm curious. we touched on some of the open source aspects a bit, but I'm curious, like, what are some of the tools that you actually use, and products, and what are the specific things that you're bringing into customers to help them solve these problems?
When you say tools, I mean, what we are building here is a product, right? So it's a single product with an installation. So it's built on Red Hat OpenShift because it provides a whole bunch of container management and cluster management related capabilities, and so it's built on that. So the on-prem version of it, right, at least, which is termed as Cloud Pak for Watson AIOps. But it's a single product. Basically, once you install Red Hat OpenShift, you install the product and you have all the capabilities that you need to manage your incidents and diagnose them, which includes resolving the incidents and avoid with some of the few proactive techniques that we've built for detecting problems early during the software development and deployment lifecycle itself. So it's no specific tools as such. But I would say that once you've installed, yes, as for any AI-infused product or an application, there is some amount of monitoring and maintenance is a recommended best practice for these models, because these models are set up to take more data in production and continuously learn and improve and all that. So the product that we're building comes with those hooks and mechanisms for humans to provide feedback to the system, and for IT operations administrators to have enough transparency to know what models are getting built on a nightly basis, which ones are getting deployed, and if they wanted to see the performance of those models and on some pre-labeled ground truth data, they can evaluate the models and such. So that's pretty much it. I mean, it's a product that you install and you start using. Then I talked about on-prem, right? The reason why I talked about there are other ones that we're building for specifically for AIOps, for SaaS as well, on top of Instana, the application performance management product that we have acquired into our portfolio recently, and we are building a SaaS version of AIOps that is to come later in the year. It's work in progress. Yeah. So other than that, it's not. It connects to various enterprise tools, as I said, for collecting the data that it needs for doing the analysis, such as connecting to log aggregation tools or metric aggregation tools or ticketing tools and those sort of things. But those are connectors which are in the product itself.
Great. Cool. And so you have everything right there in the Cloud Pak for Watson AIOps. That's really cool. As usual, we use up this time pretty quickly. It goes by fast. I want to make sure that we touched on everything that you wanted to share with folks today. If there's any other things that come to mind that we missed or skipped over or anything.
So I do want to point out about this the broader portfolio of AIOps in IBM. So we acquired two companies, Turbonomic and Instana. So if in case you're wondering what those are, how they fit in with this Cloud Pak, I wanted to make a few comments about that. At the beginning of this session, when we started, I talked about this, the North Star vision for AIOps as building this self-observing, self-managing, self-healing, self-optimizing IT systems, right? Basically, in order to optimize anything, you need to observe, you need to optimize, and you need to be able to manage. To observe, we need eyes and ears on the ground, right? That's where we collect all the data. So we need that's typically called as application performance management in the land of IT operations management. And so with the acquisition of Instana, we have that in the portfolio. We can observe all of the critical metrics and traces of the application that the systems are producing. With Turbonomic, we have the ability to proactively manage the resources on clusters. If you have heterogeneous applications running, your applications are not scaling fast enough, or they have too much capacity that's not being used properly, there's opportunities for consolidation, for better cost optimization and such. That whole area of self-optimizing is done with Turbonomic because it helps with the resource optimization, and there's a lot of those capabilities and algorithms built into that. So we talked about the seeing, observing part in the self-observing aspect and the vision, self-optimizing, right? How to scale up and down, how to consolidate so that you are better optimized and cost-wise and resource-wise. That's the second part of it. And the AIOps is the third part of it, which is all about self-managing, right? You connect to all of the observed data and detect, diagnose, resolve, avoid, and introspect. All of these aspects are built into AIOps. So together, when you put all of these three together, we have the full portfolio of being able to manage the IT operations. And when we actually put them all together and integrate them well, which is happening now, we can offer the full breadth of IT operations management. So that's the vision. That's where we're headed. But I'll kind of bring it back to where we started. So there is a lot of scope for automation. There is also a lot of scope for supporting humans in the process of IT operations management. And I say that those two in the same breath because 100% automation, while is an end goal that we want to achieve, it may or may not be possible in every situation. If you have deployed a brand new application that the system has never seen before, it has no record of it, it may not be able to have prior information to tell you, to help you avoid. So human expertise and knowledge is still much critical. So our goal is, although automation, I would call that as really in a phased manner, bring AI in the human loop, help aid humans in doing their job better, and eventually get to a point where maybe bring humans into the AI loop, where AI is taking more of the initiative and driving the automation and seeking user inputs at critical decision points or feedback as needed. It really depends, and it's a continuum. It's depending on different applications, what kind of data. It could be anywhere on the spectrum of aiding humans with AI in the human loop to humans in the AI loop. But it's got to be a system, and our vision is for this system, even while we strive for automation, for it to be a really human and AI working together to really optimize this operations management problem, so that we can help the site reliability engineers, also called as SREs in this domain, or alternatively in the old domain, IT operations administrators, whatever the title of those people are, really to help them better manage their IT systems.
I'm glad you mentioned Kurzweil earlier, Luke. I feel like that's sort of the realm where we're in, where
it's exciting that it's getting real. Things are getting real. Thank you so much, Rama. We really appreciate your time today. Also, thank you everyone who tuned in live and participated. We have Latricia Golden says, very informative. Thanks. Thank you for tuning in, Latricia. Appreciate that. This will be available for replay wherever you listen to your podcasts, and our Twitter DMs are open. Or feel free to, if you're listening to this after it was live, feel free to still send us your questions, and we'll try to get you good answers. So thank you so much, Rama. And as always, all of our episodes are available at ibm.biz/in-the-open. So thank you again so much, Rama. This has been a real pleasure, and we'd love to have you back sometime.
Thanks for having me, Luke and Joe. It's been a good conversation, and you guys have extracted a lot of good information on AIOps, and hopefully the viewers and listeners found it helpful.
Yeah.
And I will be glad to be back.
Great. Thank you, Rama. Real pleasure.
Sure thing. Bye now.
Cheers.